Hi, this is Nagasai Mamindala. In this video, we are going to analyze algorithms for finding the closest pair of points in a given set or list. We are going to compare two algorithms. The one is brute force algorithm and the other one is divide and conquer algorithm to find the closest pair of points in a given set or list of points. Now, let me explain about the brute force algorithm. In this algorithm, we compare distance between every pair of points in the given set or list and keep track of the minimum distance of all the findings. This has the time complexity of O of n square. And in the divide and conquer method, we recursively divide the set of points into two halves based on the x coordinate. We find the closest pair in each half, and while merging the results, we also check for any pair of points which are close across the dividing line. This has the complexity of n log n. Now let me demonstrate the code implementation. This function calculates distance between 2 points. This is a Euclidean distance, and this function applies brute force method to find the closest points. For example, if we see, we are iterating through the loop and we are again iterating through each point and comparing and finding the distance between all points. So if any of the distance is less than the one we already stored, we store that in the minimum distance, and finally we also store the closest pair. Once the loop runs through, we return closest pair and the minimum distance. Now let's discuss about the divide and conquer algorithm. So the this algo2 underscore DC function is the entry point for algorithm. It takes a two-dimensional list of points. It sorts the points by their x coordinates and y coordinates to get px and py and the original set p to start the recursive divide and p. Then we call the recursive function, which applies divide and conquer methodology to find closest pair of points. Now let's explore the closest pair function. Px contains the list of points sorted by x coordinate. Py contains the list of points sorted by y coordinate. P is the original set of points. Here, first we are checking the base case. The base case yeah, does not include 1 point because there should always be a pair. 2 points is also one base case, and 3 points is also another base case. So 3 points is a base case because if we divide the 3 point, 1 point will be in a separate plane, two other points will be in separate. So this 1 point cannot be used to calculate closest pair. So in the case of these base cases, we just apply the brute force algorithm to find closest pair. If the number of points is greater than 3, we divide the set of points into two halves, Q and R. Then we recursively call itself on Q and R to find we recursively call on Q and R to find the closest pairs in each half. We then merge the results from left and right halves to find the minimum distance delta among them. Here in the above these two steps, we get minimum from left and right, and we then find minimum of both of these two. Then we construct a strip of points. Why we have to do this is when we divide the points into two halves, there is a chance that the closest point, one of the closest points might lie in left plane and another closest point might be on right plane. But we only calculate each plane separately. To cover this, we to to mitigate this problem, we construct a strip of points within the distance delta because the closest point, the pair of points, if there are any, should be less than delta. We do this by sorting by y coordinate. We iterate over each point in sy, checking its distance to next 15 points to find the closer pair. Finally, we return the closest pair found along with their distance. Now let us explore how we conduct this experiment. This function helps us to generate unique points, and we have designed another function where we calculate runtimes of both algorithms. So so we take 5,000 step gap between each n value starting from 5,000. That means we generate lists of size 5,000, 10,000, 15,000, 20,000, and so on. And for each size of list, we run it 10 times. Number of iterations is 10. We run it for 10 times and we calculate average runtime. So for example, if you see here, for the in the brute force method, we have this list and we run the loop for 10 times and we append all the run times. So we start the time, run the algorithm, end the time, calculate the difference and store it in the rt underscore one variable. And in the end, we take the average of all the 10 iterations. Now let me give a small demo of, and these are the graphs, empirical graphs comparing empirical and predicted runtimes of both divide and conquer and brute force algorithm. Now let me explain a small test case. So here we took the test points, we apply the brute force algorithm, and we get we get the closest pair of points 0 comma 3, that is the point at position 0 and the point at position 3, 1 comma 2 to 1 2 comma 2 are closest with a distance of 1. uh, and again we apply divide and conquer method here. Here the closest pair of points is same with a distance of 1. The points are 1 comma 2 and 2 comma 2.